Today we are going to have another presentation on databases, focusing on inputting data. This is an issue that we are going to deal with when building any database, including the new database on EU DIAT supported by the recently awarded Jean Monnet network. So let us start. You may remember this database hierarchy from presentation number 1, which I've inserted here as a reminder. On this slide, you can see a simplified mapping of some of the most important database-related terms hierarchically, from the building blocks on the left-hand side of the diagram all the way up to the complex that we call a database, which is what we get on the right-hand end of the slide. We did review each of these blocks in the previous presentation. In the realm of databases, we have three broad types of data: structured, semi-structured, and unstructured data. What matters for us is that relational databases only accept and store structured data. That is, data possessed of some predefined properties through which it can be organized. Simply speaking, these properties are the same characteristics which define and thus limit what type of data we can input into each column of a database. Each indicator may directly correspond to a variable, or in certain cases, the indicator may in fact be broken down into multiple variables. The reason is to separate textual from numerical data, make it easy to manipulate both types whilst querying. Where possible, we can also turn textual data into booleans, finite set variables, or a combination of both for economy of operations and reducing potential imprecision. That is, to do as much querying with as little effort or possible error. When you are collecting data, you should keep in mind the shape of the database, because, remember, data is being collected for predefined datasets. Certain simple rules ought to be followed in order to gather clean data, which is what matters most at this stage. Some of these rules fall under what is called database normalization, which entails, quote, creating tables and establishing relationships between those tables according to rules designed both to protect the data and to make the database more flexible by eliminating redundancy and inconsistent dependency. End of quote. There are several levels of normalization, also known as normal forms, each of which builds upon the previous level. For example, if the first set of rules is observed, the database is said to be in first normal form. With the second rule, it'll be in second normal form, and so on. For our purposes here, which is first and foremost about gathering clean data, first normal form is the most important, at least for a start. So NF1 rules, which you need to bear in mind whilst collecting data, are as follows. Each table cell should contain a single value. Data in each column should be of the same type. Each record, that is, the entirety of a row which consists of all the individual cells under the respective columns, needs to be unique. And finally, the order of the columns should not matter. In other words, if you reorder columns, no information is lost, no error resulted. We can also require ourselves to follow further tailored rules in addition to NF1. Why? Because we want to make the database more tightly structured, efficient, and query-friendly. These can be, when designing variables, try to keep numeric and textual variables separate, that is, under different columns. Also, turn fixed value variables into binary, tertiary, etc. variables. Another important measure that ought to be taken is establishing a master list of keywords for the phenomena you study. For example, geographical names, which is standard plus always updated everywhere. Controlled vocabulary, especially for textual, that is, string variables that are utilized consistently throughout the database. Finally, in the following slides, we want to go over a few strategies or conventions that we have in place for the big DIATS database to ensure data inserted is clean. That's why the same process can be applied to any database, such as the one on EU DIATS. First, let's review a list of don'ts, that is, things you must stay away from. No dirty data. Why? Because computers are not that intelligent yet. to make sense of data contextually, the way human beings can pick out signal from noise. And what is dirty data? Dirty data means inconsistent and/or poorly structured data. In other words, data that is carelessly treated. So what does careful treatment of data entail? For one, do not treat dataset tables as if it's another Excel sheet. For example, no empty middle rows used as headers, etc. Also, do not leave cells blank, on which I'll say more shortly. Do not let pre-formatting stand. For instance, seemingly benign extra spaces, non-printing characters, markup tags, and so forth can all cause unnecessary headaches. And do not leave duplicate rows. In order to rid your dataset of such duplicates, you can filter for unique values first and then confirm that the rows in question are indeed duplicates by checking everything. And now let's review a list of do's, that is, things you must always practice in your data collecting. Be precise and, even more importantly, consistent. For example, as mentioned in the previous slide, extra or alternatively missing spaces are both important and can result in problems. Consolidate same content under related columns. Treat booleans, that is, 1 and 0 instead of yes, y, and no, n, and other fixed value columns meticulously. Next, you should spell check and change text case to standard. For instance, using the find replace function with text, formulae, formatting, or wildcard characters. Also, fixed numbers and number signs, as well as dates and times. For example, convert numbers stored as text into digits or reformat dates so dashes, slashes, etc. are not mistaken for the same marks elsewhere. And transform and rearrange columns and rows when necessary, which is only applicable to flat or two-dimensional data. Coding missing and inapplicable data instead of leaving them empty or inaccurately supplying a zero ensures that any omission on the part of data collector or database manager results in a blank, that is, uncoded cell. -888 missing data means it was unavailable for some known or unknown reason, but not structurally impossible to find. -999 inapplicable data is data that is impossible to fill, such as the number of maritime dyads for a landlocked country, which can also be 0, but -999 is more accurate. Finally, I'm going to explicate the concept of conventions through a numeric instance that we have already used in the Big Dyads database. -1982 is a cutoff point for all maritime dyads that lack dates of establishment. The minus sign is used to differentiate it from the year 1982, which refers to a real historical date. The part 1982 in -1982 was chosen because in that year the law of the sea establishing exclusive economic zones came into effect. If two states have not already an agreement establishing a maritime boundary, we have made the decision to use that cutoff point as the establishment of a de facto maritime border. Therefore, the -1982 instances refer to cases where the states have not yet signed an official agreement, whereas the 1982 dates, or any other dates for that matter, are for dyads that have a treaty in the specified year. And on this last slide, you can find a couple of links for further reading. I've already covered most of the material, but it wouldn't hurt to review these and similar resources to hone your spreadsheet skills. This is the end of presentation number 2, how to input data. Thanks a lot for watching.